Hey guys, how's it going? Welcome to this video. We're going to be talking about crawl spaces for this particular one. It's something I've touched bases on a couple of different times, but something that you should definitely understand a little bit more about. Now, I'm going to cite my sources here. I learned most of what I learned about crawl spaces from a company called Crawlspace. They have a lot of really good information as far as like dehumidifying and controlling the moisture inside a crawl space. Learned the most with Eagle Lift, actually, which is a foundation company out in Southern California, where I learned mostly about that kind of stuff. And then mostly what I'll be talking about in here will be things that are in compliance with like LA County's standard plan A, which is designed, it's like a standard plan, it's a bunch of standards and specifications or whatever to help you comply and qualify for what was called the brace and bolt program. Many counties throughout the state of California adopted the brace and bolt program, where the government would pay you to upgrade your crawl spaces in order to help with like seismic retrofits and things like that. So we're going to talk a lot about crawl space stuff. This particular video will discuss a lot of the stuff on like that standard plan and identifying terms and stuff. There is a more engineering-y and more in-depth analysis of crawl spaces and all that fun jazz that we are not going to cover in this video, so there will be a second one. But for the most part, I wanted you guys to learn a little bit about crawl spaces and seismic retrofits and all that fun jazz. This roughly 5 years ago, by the way, maybe 6 or 7 actually, 6 or 7 years ago, became really prominent in Northern California and throughout LA County when a home is being sold. Somebody goes out and the inspector looks around and they check out like the interior posts and all that fun stuff, and usually it ends up being a point of contention or a point of discount to either have the work done or discount the cost of the home in order to have the work done. So there's a lot involved in here. I'm just going to dive into it. So your crawl space, if you've got like the side face of a home, right, and then the roof or whatever, usually there's a crawl space entry. If that's grade, there's a crawl space entry that goes down here. It's just a tiny little gap. It's preferable when it's like 20 inches or whatever, but a crawl space is designed to have an area underneath the home. So you have like a window here, right, and maybe a door here, so you kind of get an idea. It's like it's a tiny little hole, right? 20 by 20 is nice. It's not always the case, but it's nice. Like it looks like a wire mesh or a grate, and that's your crawl space access, right? CS access. And they're not always that size. Some are bigger, some are smaller. Some of them would be like, if it was on this side of the door, would just kind of look like that. And then if I were looking down from overhead, right, you would have the house, and then like this would be the top of house. And then there would be an access that looks like this, and it's like a latch, and you can pull this wood or this whatever it is that's down, right? Or this thing could be recessed further into the ground, and the access would still be sideways. It's presented a bunch of different ways, but the point of a crawl space access is to access your crawl space, right? So there's a lot of reasons to have a crawl space foundation system. Many homes in California have them. I don't know, I'm neither here nor there on it, honestly. The idea of having a crawl space, you have all of your plumbing and your utilities and everything that can run through your crawl space. So if you ever have a break or a breach, or if you need maintenance or something, you don't have to cut through your concrete slab in order to expose the utilities to perform the maintenance or repairs that you have to do on that, which is cool. There's also seismic reasons and hillside reasons and mountain reasons and many reasons to have one, but one of the benefits is that you have access to the utilities like that, right? So you would go into your crawl space access, at which point you're inside your crawl space. The smallest one I've been in was like 10 inches tall, okay, up to 19 inches tall. And you have to understand, when you're getting estimates from contractors in order to do like crawl space or seismic repairs and stuff like that, if I've got to dig in order to get to where I'm going, in order to stabilize stuff, there's going to be a lot more labor costs involved in all that, right? If you're in a 19-inch tall crawl space between a girder and the floor, the soil, every time you crawl underneath, you have to hold your breath, and then your chest is on the floor, and your back is against wood, or flop that around if you're upside down, and your back is against the floor, and your chest is pressing against wood, and like body parts are getting snagged on stuff. It's very uncomfortable to be working underneath a house like that, right? It's like the epitome of confined space. And guys, if you want to make people happy, just like defog, what do they call it? The underside, like get the insects out. I hate crawling through and getting like black widows or ants or snakes or rats or cats or it's nasty under there. Okay, so a lot of what you're paying for is that kind of stuff. So if you look at a stick of wood that's $35 and then you had 2 of those and 2 bases and your material cost is like $150 or whatever in order to do like a very small repair, and your material cost is like $150, but you're still getting a quote that's upward pushing $900,000, right? That's not just company overhead, and that's not just material, right? The labor that it takes in order to get things in there, it's very difficult for the workers. It takes a lot of time, so on and so forth. So you're paying for all of that stuff on top of course, profit. So anyway, you got the crawl spaces. You got the crawl space access to get in, and then it's just this void underneath the house you can crawl around on, right? If you have a slab on grade, you have a concrete floor, and you can't crawl underneath it. If you have a wood composed floor and you can crawl underneath it, it's a crawl space. It's a raised floor foundation system. Now, very important, there's 2 types of raised floor foundation systems. The first one is where I'm gonna pretend like this is a floor, right? I'm looking down at a floor. There's 2 types inside the crawl space. The first, you have your floor joist. Ignore that. We're gonna get into joists and stuff, but from the bottom, right, you either have wood beams that span the distance of the home. Okay, this wood is called a girder, 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 and this wood should be roughly 4x6 or bigger, right? In order to sustain a lot of the loading. Now, generally for raised floor foundation systems, there's not going to be any significant loading on the floor, like 3 kip stops, right? 3,000 pound stops. Moving in grand pianos and then granite countertops and all that fun jazz, that obviously adds a whole lot of weight, which can cause deviations in the floor. So it's a consideration to have when you're trying to decide if you want to buy a home that has a raised floor foundation system. If these girders are composed by 4x4, which is what you see in a lot of older homes, oftentimes this needs to be changed out. Well, this whole thing needs to be changed out, upgraded, or you have to limit the amount of loading that's done on the inside of the home, right? The other type of crawl space can span the entire distance, but most often will do things like this. And this is generally 6 to 8 inches of concrete. Okay, and this is called a stem wall. So more specifically, this is called a raised floor foundation system with all the wood elements, wood components, and interior posts, which we'll talk about in a second, and blah, 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 blah. A stem wall foundation system has a bunch of concrete, like a bunch of mini footings that are running throughout the crawl space. And then on top of all this concrete, you've got your little sill plate and then each of the wood beams that all post up to underneath the floor joists and blah, 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 which we'll talk about in a second. But just bear in mind that this is going to have interior posts, which is going to be a subject of conversation in a moment, okay? This generally doesn't have interior posts. It may have a cripple wall, which we'll talk about in a second, but this is mostly supported by wood elements on top of concrete, and the concrete spans the whole distance, right? And in order to access something like this, which spans a whole distance, they usually cut a hole in the concrete, maybe all the way through, not often. Oftentimes they leave a little 2 or 3 inch bridge over the top, so it's still one continuous piece. But this is a stem wall foundation system. Stem wall. This is just raised floor wood elements, right? Raised floor wood elements, stem wall foundation system. Very important. What? Did I just? Yeah. Awesome. Crap. Oops. Anyway, so crawl spaces. You have stem wall, whatever. Okay, so now I'm going to go into the crawl space What am I looking at? We talked about the girder, right? Girder. And this is 4 by 6, generally speaking. If it's shorter, you're probably going to get a recommendation to make it bigger, right? If it's 4 by 4, probably recommending to be bigger. Now, again, if this was a stem wall foundation system, sometimes there's a girder, sometimes there's not, but there would be a concrete stem wall there, and then there would be these little 2 by 4s that support it the whole way. And sometimes they've got like diagonal cross bracing on it. That's actually a good design, right? But that's not what we're talking about today, though. What we're talking about today is interior posts. So interior posts is going to be this wood element here. And this wood element is generally 4 by 4. Okay, now this is just the post piece. That's the wood, right? The entire interior post consists of the post and the base. The base is generally concrete, oftentimes in the shape of a pyramid. Now, this goes from like 10 by 10 to 12 by 12. Some people will put it directly on grade like that. Some people will put a lot of this concrete element. I'm going to try and do this. I suck at this. Like that, so the bottom is buried, right? And some people, and per the old building code, and I think actually possibly still in the IBC right now, this couldn't be a concrete pyramid base. Before, they would force you to excavate down and fill this whole thing with concrete. And then you put an attachment and attach the wood to that, right? So that's old building code stuff, and that's actually really, really good too. But in a retrofit application, it's very, 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 very tough to dig down, however far you're going to dig down, and we'll talk about that in a different technical video, right? Very difficult to dig down and then drag either concrete bags or a pump or whatever. If you're doing 40 of these, you probably want a pump in order to fill all this with concrete and then let that set before coming back and setting your wood elements, okay? So very, very, very difficult to pull off like that. So most people nowadays will defer back to these concrete bases. Now again, thank you to this Crawlspace company. They like to they'll dig down anyway, right? Then they'll put an engineered fill inside here. And inside the engineered fill, which they'll compact, and then they'll put this wood on top. Later, we'll talk about how you design stuff like that, okay? But that's the essential composition. So no matter whether this is buried concrete or this is a concrete base or whatever, you need to find some sort of a strap or a tie or something to anchor this wood into this base, okay? Now, oftentimes that comes in the form of a Simpson anchor, which often is in the concrete base already, or it's something you can sink into the base or sink into poured concrete, right? There. Or some of them use like an epoxy with wood that you can just kind of, if this was a wood base on the top of your pyramid base, and this wood is epoxied onto the concrete in order to attach it, and then they try to like screw downward with a minimum of 4 screws on 2 sides in order to attach the wood to the concrete. The point is you're attaching the wood to the concrete. That's what you have to do, right? Attach the wood to the concrete. Then you need to attach the wood to the girder above. This again comes in the form generally of like a Simpson. Now, Simpson did so great marketing that there's other metal straps that exist and literally like nobody knows the name. I'm kidding, everyone knows the name. But when I say Simpson, everyone knows what I'm talking about. It doesn't have to be a Simpson strap, but Simpson is the most widely known, widely used, and widely accepted product. So your Simpson T66 straps or L66 straps, which are all screwed in order to attach this wood to this girder, right? So these are the seismic straps that we're talking about. By the way, some people like to use post caps, Simpson post caps. Some cities do accept that, where it's got like what? The base down here, and then the base here, and then the base here. It looks like that. So they screw in the sides here and here, and then put 2 in there, and then, or 3, sorry. 1, 2, 3. And then the other side, so now you've got, what, 3, 6, 9, 12 screws that are already holding this one thing. It's really convenient, actually. But that's all it. So your interior post, remember, is all that. You got your little 4x4 wood. It needs to be strapped to the concrete, whether that's poured, pyramid, block, whatever it is. This wood needs to attach to the base, right? We'll call that a base. Base, hey. And wood needs to attach, the post needs to attach to the girder. Those are all the important elements. So when you're doing maintenance on something like this and you have to like level a floor or do something like that, they should always be doing this. Now, very officially speaking, using shims is illegal. It's super against the building code. So if there's like a gap here, right, it's super easy to buy that $5 pack of shims and then just like hammer the shims in here in order to restore the support. The reason why that's not seismic compliance is you can imagine the floor rolls during an earthquake or whatever, right? That impacts this, which impacts this. And as soon as this connection starts doing this with your earthquake, those shims are going to fall out, which can create a depression or, in really bad situations, a major catastrophic failure right away, right? You're taking all of the support out from under something at one time. It's terrible. So not recommended for shims anyway, although those are easy adjustments. That's a technical video. So yeah, this is sort of all the elements that make up your girder and interior post foundation system. Now where this girder goes is important. All right, dropped it. So if the girder goes, right, and I've got my little footing here, and this footing would actually be underground. So this is grade, right? And then you've got what? Pyramid base, boom, and you've got your girder. But this is concrete, because this is my home footing, right? It's the footing on the perimeter. How this girder attaches to this here is very important. So you might have a sill plate, and this sits on top of that, right? This sits on top of that. Some people cut a notch into the footing like so, and the corner of this will sit into this, right? Some people don't do any of this, and they just leave this free floating, right? Not recommended, but if you do that, you should probably put an interior post like right here in order to support that. Otherwise, if you have a dip down in the corner or the perimeter of a home foundation, that's what's gonna happen, right? You take this support away and then you put loading right here. This is all supported, and just like the piers we talked about, the support here is strongest directly above. Then that support like wanes down in a sort of pyramid-like thing, right? Like so. So once you get past that, there's no support. So this could dip down. This girder could dip down over in the corner, and if you're by the perimeter and that happens, it's a very common cause, right? And this is also important because if I've got a post over here, wow, what a terrible base. If I got a post over here, and this sags down like so, boom, what that's telling me is that the overlap of the support of this pier and this pier, right there, that overlap, needs to be strong enough to support all the loading on top, right? If the combination of this and this at this distance supports only 300 pounds here, and you put a 500-pound piano, I'm not even going to draw that, piano on top, and that's 500 pounds, right? That is 200 pounds differential, and you create the dip. And you solve that by putting another post on the in-between and lifting up. Wow, that's terrible. So that's sort of analysis of like how you get bowing floors and stuff. While I am about to bring up the next points, I would say it's very common in crawl spaces to have like squeaking floors, okay? Especially walk through older homes, whatever, you take a step here and the corner over there is making a creaking sound. That's normal because you have, post, girder, and then there's these little 2x4s generally, which are pretty closely spaced together, 12 or 16 inches or whatever. And these are all, what, 2x4 pieces of wood called the floor joist. And those are overlain by plywood. Usually, what, 3, 4, 5/8 inch, half inch, 5/8. Excuse me. 1/2 inch, 5/8 3 inch plywood, and that's your floor inside the house, right? So what happens is over time, whether the wood is expanding or constricting seasonally, if it gets wet, if there's different elements that impact stuff, it can create small spaces here or small spaces here. This is the one time that I support the idea of a shim, because you're not going to be correcting anything more than like 1/10 or 1/4 of an inch or 1/5 of an inch, right? Because you put some shims in there and take the creaking away and life is good. Also, most people don't realize that when you have a raised floor foundation system, like your drainage, it's recommended to go through your rain gutters and your subterranean piping twice a year, make sure to make sure everything is clear. You should also maintain your crawl space at least once a year to make sure the creaking and cracking and all that fun stuff doesn't go away and become a bigger problem later. Meh. So the main point that I wanted to talk to you about, or not main point, the next point I actually wanted to talk to you about, last kind of point that we talk about. So if I'm looking at the perimeter wall, right? So the girder is 4x6, looks kind of like that, 4x6 girder. And you got all your floor joists running like so. That's 2x4 floor joist. And then like girder, you got your interior posts, which go down. And your base. Do you follow? Base, interior post, and we'll just call grade here at the base. All right, so we got this. We've got, I'm looking at the perimeter, right? We've got the stem wall, which is the concrete. That comprises, I lost my other color, I'll just use this. Stem wall. This is the concrete that you see from the inside of the crawl space. It goes down underground, right? It would go further than below grade, however low it needed to go in order to do that. Now, on top of this stem wall, looks like a couple different things. You're gonna have your sill plate, which is a laying down piece of whatever. And that should actually be there, but anyway, how can I word this? From the top of all of this stuff to the bottom of the girder / the start of your floor, right? You have, if you have wood elements, little 2x4s that look like so, and sometimes they have those little fire breaks or whatever. If you have those wood elements in the back, this area, hey, look, I found it. This area is called your cripple wall. Cripple wall. It's not a nice word. We can call it a disabled wall. Terrible joke. I'm sorry. Anyway, it's called a cripple wall. Now, for your brace and bolt program, what happened, or what they want you to do, is to take plywood and cover all of this with plywood. And when you cover your cripple wall with plywood, and I think it's like, you gotta have like 10 inches or something like that or more in order to do that. It's not every crawl space. But when you cover it with plywood and you actually screw the plywood into all of these wood elements along your cripple wall, it stiffens everything up, right? It ties it all together and locks it in. So it makes it super, super, super strong and very unlikely to bend, bow, tilt, lean, twist, or do anything like that during a seismic event. So these cripple walls are very, very, very important as well. That's sort of it as far as introduction into crawl spaces go. We're gonna have a technical video that talks about a couple things. There's one point I wanted to bring up on this video. All right, this is definitely a design thing. It's getting a little more technical than I want to be, but it's important. So if I have a crawl space, I've got my girder, right? I've got my floor joists. I've got my wood, plywood. This is my house, yay! And I've got an interior post, and I've got an interior post. And let's just say, even if this is notched into my, ooh, it's terrible. Even if this is notched into my footing, like so, even if this is notched in, whatever it is, if this footing settles, right, this whole thing bends down, right, whole thing, this all the way, 4 feet, theory, 5 foot more. This last interior post is probably within 5 feet. And this whole thing settled, right? So if you're gonna have your foundation treated, whether it's foam, mud jacking, push piers, helical piers, cape, doesn't matter. Doesn't matter how you get this treated. If you treat this and you lift this up so I can re-level my house floor, you have to consider at least this last pier that's closest to that footing, because more than likely you're going to lift this and this will create a gap. Okay, so that can create creaking, cracking, squeaking, so on and so forth, but just as importantly, it can create soft spots or waviness in the floors that need to be addressed later, right? So if you have a foundation repair contractor come out and they're talking about lifting your perimeter foundation and you have a raised floor foundation system, keep into consideration this here. It's very, 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 very highly likely that that will need to be adjusted and or replaced when you go, which by the way is a great time to do everything else in your crawl space, but you know, your choice, not mine. That's it. If you guys have any questions, comments, concerns, leave it in a comment below or message me directly. And please like, share, subscribe, and do stuff like that. Thanks so much. You have a wonderful day. Hey guys, I'm putting this at the end because I forgot to talk about it during this entire long video. Sorry for this one being so long. But there's 2 more things about crawl spaces. One, yes, the access point can be inside a closet inside the house. Be prepared for challenges during crawl space repair if that's the particular instance, because it's very difficult to get the wood elements into a closet and then into the crawl space while it's still going to be very long. So that usually adds cost if you're not going to build an access point or use one of the crawl space vents or something like that for the repairs. The other thing is any repair system that you use on the inside of a crawl space should generally be used with pressure treated wood. Pressure treated wood helps resist the elements and the moisture and prevents wood rot and all that fun stuff. And according to the International Building Code, and I think the California Building Code also, any wood element that sits within 10 inches of the soil has to be pressure treated anyway. So all of those wood posts, yes, must be pressure treated. And then the girders that we were talking about running across, sometimes you can get away with that being like normal wood, but if you're doing a job and you want to do it right, you might as well pressure treat that as well. So just tacking that on the end before I get asked about it. So my bad. Thanks.